Hello, everyone. It's an honor being here as being presented. I'm Pedro Ferreira, and I work at SPRAYTECH. And it's always an honor being here in such an important event again. It's my second time at IAPA. I was last time in Münster, in Germany. So today, I'll be presenting some of the studies that we've conducted last year among some of our clients and partners. Just check here, the laser is working. So I'm Pedro, and these are the colleagues that helped me in the work itself. Marielle, Gabriela, Professor Marcelo is here, Luis, and Mateus. So just before I start talking on the presentation itself, the research, SPRAYTECH is a Brazilian company. We're a family business company, and we're specialized in pesticide application technology. So we do this spray. We're actually a spray contractor, so we do this spraying for farmers. So we mostly spray sugarcane, soybeans, corn, and other crops, sorghum, and so on. But we also are on sales, doing representation, for example, spray nozzles like T-Jet is here, MagnaJet, a Brazilian nozzle company, selling spray parts and etc. And we're also on consulting and research in pesticide application technology as well. You guys are more than welcome if you guys want to know for future possibilities and partnerships in Brazil and SPRAYTECH. And everybody's more than welcome to go down Brazil, visit some of our operations, check out how a pesticide application is conducted in Brazil. So the work now itself, talking on the background, the presentation today, I didn't mention the title, but it's basically the effect of application volume and nozzle types on pre-emergent herbicides in sugarcane. So I'll be talking a lot about the water volume rates, and we saw some earlier presentations mention that aspect in previous applications. And every time we're talking on water volume rates, we must consider some aspects, some factors. For example, the application method and equipment it's being used. We all know that aerial spraying, for example, uses way less water than ground spraying, either if you're using a knapsack or an orchard sprayer. Drones can spray from 10 liters per hectare to 20, 25, and so on. And orchard sprayers, we've seen some, I think, Lars presented, for example, and some other data showing up to 5,000 liters per hectare, depending on the crop size and the orchard we're talking, that we're mentioning. Other aspect that we should consider too is the type of product that's being used, either if it's an insecticide, a fungicide, or a herbicide. Different products may require different amounts of water in order to, if, for example, it's a contact insecticide, it may need more water and more coverage to cover that target and give better product control. And also some products may need more water in order to solubilize and get properly worked out with the water and mixed up and then work properly. And even sometimes when you're talking about the same product, for example, here we have a Brazilian label for herbicide, a commercial product label here for this post-emergent herbicide called mesotrione. And here's a second product label for the same exact herbicide, the same exact active ingredient at the same concentration, just two different commercial product labels. And what both these herbicides are recommended in sugarcane. And what comes to our attention is different labels recommending different application volumes for the same herbicide and the same active ingredient concentration. So growers and farmers and applicators may find themselves in Brazil a little bit lost. I don't know if it happens sometimes here in Europe, in other countries, but they can get confused and say, hey, I should either spray at 100 or 300 or 200. So these are some considerations that you should take into. Other aspects when you're talking about water volume rates is the plant development and the size of the target that you're spraying, the structure, how big it is. Of course, when you consider, for example, in this first picture here, young plants of coffee, we may need to use less water than as plant gets older. Higher foliage, more density plants, bigger and more difficult targets and structures. So we need more water in this case here to better penetrate and give better coverage. So unfortunately, what I've seen in Brazil and from some talks here that I've heard over the past 2 days is that unfortunately farmers, they don't do these questions, those basic questions of when I'm spraying, what I'm spraying, and how I'm spraying. So regarding application volumes, for example, usually what I've seen in different regions and different in crops, usually they just tend to stick with a number. So I like the number 200, so I'm going to use 200 liters per hectare for everything. It doesn't matter what product I'm using, it doesn't matter what nozzles I'm using, or it doesn't matter the type of target that I'm applying. Usually they just stick with the number and just go with it doesn't matter the case. In sugarcane, just giving a background, ground applications usually are within the range of 150 to 300 liters per hectare. It doesn't matter if you either spraying a herbicide on a product before or after sugarcane planting, or if you're using a product right after sugarcane harvesting, spraying on pre-emergent herbicide here, for example, or in later stages in sugarcane. Usually, these are the application volumes used. And we all know that as we increase the application volumes, the water rates, efficiency, and the spraying efficiency, operational efficiency goes lower, either for applicators and farmers, and also it lower will be your water efficiency. Not only with product use, we try to be more sustainable, and also we should consider using less water. If that's the case, of course, we should consider all aspects in that scenario. So for a farmer, we will mean if he can use actually lower water volumes, saving costs and saving water. So the reason why we wanted to do this research, first of all, no related research has ever been conducted in sugarcane. There are some research out there in the literature for some different crops like soybeans and corn regarding application volume and nozzle type, but nothing on sugarcane. And second, because sugarcane is a completely different reality, especially when you consider the amount of sugarcane residue that's left over on top of that soil after sugarcane harvesting. We're talking about here, you can see the picture, so the harvester here on the left side, and the amount of crop residue that's left on top of that soil, creating a barrier that's going to impede herbicides, especially pre-emergent soil-applied herbicides, to reach the target, which is soil. So here we can range from 15 to 20 tons per hectare of crop residue. So it creates a thick layer of crop residue. And third, and not least important, it is, of course, of interest to growers and farmers and applicators to understand if either using more or less water is going to improve or not their herbicide applications. So the objective of the research today was, first of all, to evaluate the application volume and the nozzle type effect on either droplet size, then on spray coverage, and then on herbicide efficacy for soil-applied herbicides. So the methodology, material methods, we conducted this study last year in 2 locations. We do intend to conduct in 3 more locations this year in order to get a more robust data set. But studies were conducted last year during the dry season, usually in June, July in Brazil, in the southeast part of Brazil is the dry season, so not much rain, in 2 fields. The herbicide tank mixture was a mixture, a premix, 2 products, but one product was only one herbicide, another product was a mixture of these 3 here at a standard and tank mixture rate. We tested 2 different nozzles, the AIXR from TJet and the MUG nozzle from MagnaJet at different nozzle orifice, O15s, O2s, O3s, and O4s. And we compared those treatments at different application volumes from 40, 80, 120, 160, and 200 liters per hectare. Spraying applications were conducted using a self-propelled sprayer from Jacto, a uniport model, at a constant pressure of 230 kPa. And we only changed speed depending on treatment, depending on application volume. So if it was a lower water volume treatment, we would have to speed up the application. If it was a higher volume treatment, we have to apply slower. Spray coverage was assessed using water-sensitive papers and then later analyzed in ImageJ software. And droplet size analysis was conducted using a master size analyzer and standard methodology for droplet size measurement. Weed control ratings were conducted then at 14, 28, 56, and 112 days after applications. Those are the most common weed species observed in both fields. First one here, castor bean. Second one, morning glory. The third one here, wild bitter gourd. And then guinea grass. So on droplet results first, I know this is a big table with lots of information, but just like to point out that as using the standard classification, using reference nozzles, we were able to get the droplet size classification for those nozzles. And then looking only for the first nozzle here, the MUG nozzles, the first thing that came to our attention was that by increasing both nozzle orifice and also increasing the water volume rates, we saw significant increments on droplet size. So greater droplet size. So one might say, but you guys also changed nozzle orifice, and of course, changing nozzle orifice, we would expect to change, get changes on droplet size. So when you only compare these two nozzles here, the same nozzle orifice, O4s, and only changing the water volume rates, so increasing water volume rates, we also saw significant increments on droplet size. So meaning that more diluted tank mixtures significantly increase droplet size for this nozzle in particular and this tank mixture. Similar results have been reported in the literature. And we could infer from these results, again, for this specifically nozzle and this specifically tank mixture we're talking about, by increasing the application volume, we could then potentially reduce drift for these applications. Another characteristic of this nozzle here, meaningful to mention, is that it does produce a low drift potential in general, regardless of the nozzle orifice or the water volume rate. Now on the AIXR results, differently than what you saw from previous results from the MEG nozzle, we saw that by changing the water volume rates or the nozzle orifice, we didn't see any differences on droplet size. So the increase in no apparent effect on droplet size. Similar results have been reported by Creech. And when we only look at both nozzles, both the same nozzle orifice, both O4s, we can see that was actually the opposite that happened in comparison with the MEG nozzle. The highest water volume actually produced the lowest droplet size in this particular here. And another thing worthwhile mentioning is that, of course, as we expected, this nozzle, by producing medium droplets, would have a higher drift potential in comparison with ultra coarse nozzles. So now looking, before I show you guys the droplet density and the spray coverage results, just another way to look at the droplet size results here, we can see a clear effect of, by increasing nozzle orifice and also the water volume rates, we saw this increment on droplet size. And we did not see the same for the AIXR nozzle. Now on spray coverage itself, the results for both nozzles we saw, as we expected already, by increasing water volume rates and also nozzle orifice, we saw increments for both nozzles on spray coverage. And a particular, an interesting result here was for 3 application volumes in particular, volumes of 40, 80, and 120, we didn't see much differences between nozzles. So we would expect, for example, by using a nozzle with ultra coarse droplets to have lower spray coverage than medium droplets, for example, but that was not the case for these 3 application volumes. Now on droplet density results, the number of droplets per area, even though data was not significant, just here showing the tendency of, for this nozzle in particular, not much difference. As we increase nozzle orifice and the application volume, it didn't increase the number of droplets per area. And for the AIXR, we did see some differences, slight differences, but worthwhile showing to you guys. And now on the weed control results regarding the application volume and the droplet size effect on it. For the first meaningful evaluation data, 56 days after application, what we saw was that it didn't matter if we're either using lower volumes, 40 or 80, or higher volumes, 160 or 200 liters per hectare, or if we're using coarser droplets or medium droplets, results were not significant. At 112 days, same results. It didn't matter much. In practical terms, what that means for a farmer or an applicator, he could use lower volumes while maintaining application efficiency, and also maybe by using droplet nozzles that produce coarser droplets, he could even have a safer application regarding drift control. Similar results have also been reported in the literature for other crops, not in sugarcane, but no nozzle effect and also no application volumes effects for pre-emergent herbicides in different crops and targets. And just a way to try to explain why this happened, here we have a picture trying to simulate what happened in the field. So First thing that's worthwhile mentioning is that these applications, as I mentioned earlier, were conducted during the dry season in Brazil. And usually that's when the farmers apply those pre-emergent herbicides. So because it's usually in the dry season, those pre-emergent herbicides, they must have some considerable solubility in order to, in any rainfall event, they have to be easily mixed up in the water and be diluted to get, so have the possibility to wash off from this thick layer of crop residue here. We're talking about, in both fields, an average of 19 tons per hectare of sugarcane residue on top of that soil. So this is what happened. I'm just trying to simulate here, either if you use ultra coarse droplets or finer droplets in each case, or either a lower or higher water volume. What happened was, we sprayed those herbicides, those droplets were captured by the crop residue, right? So they remain over there on top, just waiting for what? What do you guys think? For some rain. So that's what happens. And so that's why these herbicides need to have high solubility, because in the event of any rainfall, they must to be easily washed off and then gets to the soil solution where is going to have its impact. So that's what happened. Then herbicide was moved down to underneath its residue, and then could have its effect, herbicidal effect, and prevent weeds from emerging. Okay, so you may say, but you guys didn't calculate any of this, you guys didn't measure any of this, so you're just speculating. But there is some data out there to support our story, our hypothesis. Carbonari, for example, he did see, and authors, they did see that 20 millimeters were enough to provide maximum movement of another pre-emergent herbicide, sulfentrazone, from cane residue in different amounts of cane residue, from 5 to 20 tons per hectare. 20 millimeters of rainfall was enough to move the herbicide to the soil solution. And similar here for other herbicides like metribuzin, hexazinone, 35 millimeters were enough to move those herbicides in a different study from Araldi to move to the soil solution, and 50 millimeters for atrazine, clomazone, and diuron. Okay, so with that, the take-home message regarding droplet size results. For the MUG nozzle, we saw that increasing water volumes, we also saw an increment on droplet size. For the AIXR nozzle, we did not see the same effect. So, and for spray coverage, we saw that despite droplet size differences between nozzles, we saw similar spray coverage for these water volume rates at 40, 80, and 120 liters per hectare. And finally, on weed control, we saw that application volume and droplet size didn't matter much for these soil-applied herbicides, probably and especially because these herbicides it's not the water volume and the droplet size that's going to play an impact in this case, and more the rainfall, probably the time that rainfall is going to happen and the amount of rainfall that's going to happen after those applications. So with that, these are the references that I've cited during my presentation. Previous presenters already talked about these events as they're going to happen in Brazil in the future. Everyone is more than welcome to attend. And with that, I thank you. Here's my contact. If you guys have any questions, more than welcome to elucidate. Thank you.